Alright, so the purpose of this final video is to talk about derivatives, power rule, product rule, and quotient rule. So what a derivative is one of the three branches of calculus, and power rule, product rule, and quotient rule basically help us get to the derivative. So let's get into it. Primarily, a derivative is a function that we create that discovers the instantaneous slope or the instantaneous rate of change of an existing function. So for example, if we just draw a function here, and we want to find out the slope at this given point, we can't just use the slope formula or anything like that, because we're only trying to find the slope of a tangent line or a line that only touches the formula at one point, and the slope formula requires us to use multiple points. So what the derivative allows us to do, it's a formula that allows us to discover the slope at any given point of a function that has any form of curves. And it can be written in a number of notations. You can either write it as f of x prime, meaning that this derivative is the derivative of f of x, or we can write it as d over dx. So to find the derivative of any given function, we can use one of three strategies, which we're going to go through right now. The first one is named power rule, and it goes as follows. But the thing with the power rule is that it only works if all of the values in the function, even if it's just one, are combined by either addition or subtraction. So let's break down the formula. What this means is that it's saying the derivative of this function is going to equal this process. What this process is you're basically getting the exponent, turning it into a coefficient, and then subtracting one from the exponent. Let's go through an example. Let's say we have x to the power of 4. The first step is to bring the 4 down into a coefficient, and then our second step is to subtract 1 from the power. And this is our derivative. Now, if you have multiple values in your function, what you want to do is you just want to add and simplify them. And ultimately, just go through the power rule one by one. Now, if there's already a coefficient in your value, what you want to do is when you bring it down, you just multiply your power by your coefficient. And this would be your derivative. But frequently, what you have to find is the derivative of a function being multiplied by another function. And then we would use the product rule. And it goes as follows. So the product rule is a lot simpler than it looks. Ultimately, what it says is that what you should do is get your first function and multiply it by the derivative of the second one. Then you should add the result of that to the second function times the derivative of the first one. To find the derivative of the first and the second function, all you have to do is use power rule. Then when you've undergone the process, all that's left is to simplify. But now, what if we have a function being divided by another function? That's when we use the quotient rule. It goes as follows. And although it looks scary, it's a lot simpler than it seems, and it's just like the product rule. So what we do, the function on the bottom, we multiply it by the derivative of the function on the top, and once again, we use power rule to figure that out. Then we subtract it by the function on the top times the derivative of the function on the bottom. And then we use power rule to figure that out. Finally, we divide all of that by the function on the bottom to the power of 2. The only gist of the quotient rule is that g of x, or the function on the bottom, can never be equal to 0. Because if it is, the denominator will be equal to 0, and the function will be undefined. So in the end, we've learned what derivatives are, and we learned how to get to them by using 3 different strategies that each have their use. Now I'm going to put on the screen 4 different problems, one for each strategy, plus one utilizing the process we learned in the beginning. Thank you very much, and I hope you learned something.